So yeah, my name is Jaya, and I'm part of the NIM core team. I myself am primarily a theorist, but I've been working with NIM for the past about 2.5 years, been responsible for pretty much everything that kind of connects the dev team to the external world, right? So explaining to people why NIM matters in the world in a variety of ways, and also working very closely with our community of node operators, which, as you'll see, is a very, very important part of NIM. So what I'm going to be talking about today is a new project that we've got up and running. It's the NIM VPN, and it's in alpha mode, and you can try it while you're here at CCC. So you should come and see us at the Critical Decentralization Cluster if you want to give it a try. But I want to try and achieve two things with this presentation, both give a little bit of a taste of the VPN, but also introduce the NIM Mixnet, which is the underlying infrastructure of the VPN. And also explain why these two things bring together the best of both worlds. You used that term also in the previous presentation. It's a good term. So yeah, I'll start off with talking a little bit about the Mixnet, and then we'll flip over to the NIM VPN, and Sarinka will join me at that point and give a live demo, so you don't have to just take our word for it. It is also a real pleasure to be here because we actually launched the NIM testnet in 2019, where Harry Halpin also joined the Critical Decentralization Cluster to do that. So it's a nice full circle. We're no longer in testnet mode. We have a live operational Mixnet. We have various nice people in the community who are integrating it into apps already, and then now we're launching our own app, the VPN. So it's nice to come full circle and to be here. So to start off with the overview, what is NIM? So in short, NIM is a decentralized Mixnet. That Mixnet is run by currently 846 mixed nodes across the entire world. Those mixnets, or those mixed nodes, alternate. So we have what's called epochs, where with every hour a new topology of mixed nodes surface and run the mixed node for that hour. We have what the Mixnet actually does is on your client we wrap each packet in what's called Sphinx encryption, which is a type of onion encryption that makes all packets look identical. And those packets are then sent through 5 hops, so an entry node and an exit node, and in between we have 3 what are called mixed nodes that actually mix the traffic or the Sphinx encrypted packets with other people's encrypted packets. So what the multiple hops actually does is it enables people to unlink the origin and destination. So it protects the IP address between sender and receiver. We add cover traffic as well that prevents traffic analysis. So the dummy traffic makes it kind of near impossible to trace the packet from one end to the other, even for adversaries that are watching the entire network. What mixing actually means is it means there's micro time delays that get added in each mix. So a packet goes into a mixed node, micro time delay happens, and there's a kind of reshuffling of the packets, right? Which means if someone's watching that mixed node, they can't actually see, when one packet exits or enters and exits again. This network, this decentralized network, is fully decentralized, including the directory authority. Now, I know that a lot of people at CCC are quite skeptical of especially the words blockchain and Web3 for very, very good reasons. But there are certain, very interesting use cases, and this, to our mind, is definitely one of them, where we actually use token economics in order to decentralize the directory authority. So what that means is mixed nodes get selected for each epoch on the basis of a combination of their reputation, meaning the stake that a community of token holders have put on that node, and their performance. So, the token economics enables a kind of constantly shifting directory authority that is fully decentralized. And the token also enables us to ensure that people don't have an economic incentive to spy on people, right? So this is a way to also defeat the surveillance business model. We want to make a network that's economically sustainable for operators, and where that economics is not dependent on the gathering of user data and selling on of user data. So what does the mixnet actually achieve in the real world? So I already said it protects IP addresses. It also protects metadata. In kind of like more plain speak, what that means is it protects the patterns of communication. So if someone is watching an entire network and they're looking at patterns of communication, those patterns can be used to de-anonymize people to find out a lot about them, including their mental state, their economic status, and so on and so forth. So it's a way to protect the patterns of communication across the entire internet. As we're moving into a kind of era where pattern recognition and artificial intelligence and so on is becoming increasingly important, protecting our patterns of communication is becoming increasingly important. And what that also means is that it's not just about protecting the content of messages, so-called data, but increasingly also, or more importantly, the metadata of messages. This is a slide that I steal for a lot of my presentations. It's actually originally created by Claudia Diaz, who's chief scientist at NIM. And it's just wonderful because it explains just how much metadata actually reveals and how much of it is out there in the world. So in short, what is metadata? It's the origin, destination, time, length, and other detectable patterns about communication. So not the content, but everything about what's happening as that message gets sent across. And metadata is in fact exposed by default across all internet protocols. And it is highly available. We've got a good list here: internet service providers, internet exchanges, autonomous systems, BGP routers, the entire internet backbone. Essentially reveals metadata. It's an entirely unprotected area, and it's not protected legally either. It has much lower legal protections. It's also what Claudia likes to term the food of machines. So it's extremely easy for machines to read metadata, which makes it particularly vulnerable as we move forward. And of course, the famous Snowden revelations showed that the NSA surveillance programs were heavily focused on metadata. So a little bit more about the MixNet. This is a quick kind of snapshot of our Explorer. As I said, 848 mixed nodes all over the world. There's a kind of cute, very orange spot in Germany. So, we have a good community of node operators here already. And like I said, the topology of active nodes changes with every epoch. So as you can see here, at the moment, we have a topology that sets a mixed net of 240 mixed nodes. That active set can expand. So, as the demand for the network grows, the number of nodes will increase. But we're keeping it small for now to not kind of rinse the reward pool early on until there's actual usage. And also to make sure that we can, really push the quality of node operations and make sure that we have, a good, high quality node operators, which is one of the things that I would like to talk to you about, because we are looking for more node operators. We're going to be running a node operator workshop tomorrow at 3 p.m., myself and Serinko. For anyone who's actually interested in just learning a little bit more or trying things out, or also discussing some issues with us, because we're looking at policies like the Tor null policy and this kind of thing, but more on that later. Looking a little bit closer, what happens? There is you on one end. You want to say hello to your friend on the other end. TCP IP or UDP packets, then enter the NIM client, and the NIM client encrypts it, as I said, in Sphinx encryption. So Sphinx encryption is a layered encryption that, as I said, make all packets look exactly identical, and then that gets sent on to 3 layers of mixed nodes. And you can see here there's the active set of mixed nodes, and then you have nodes waiting for their turn in the next epoch. And those, with each hop, the kind of connection becomes delinked. So you cannot, due to the way that Sphinx encryption is structured, every node in each layer only knows the next hop in the network, right? And then out goes the packets on the other end and received by by your friend who also wants to say hello. What's not here is the entry and exit nodes, so the gateways, which we'll talk a little bit more about later. Here's our wonderful node operator community. And I want to kind of just flag this because we do have an extremely diverse community. So people who join NIM for a lot of different reasons. We're a very diverse community. So you've got like some crews who set up nodes for social good, and what that means is they'll take the rewards that they get in NIM tokens and they'll donate those to good causes. So they'll usually talk a lot about that, and then that'll be a way for them to attract stake from the community. So they'll say, we're working very closely with this social project. If you donate or if you stake on our node and we get higher reputation, we get more rewards, and then we can kind of pass on the rewards to the community projects that we're involved in. Then of course we've got nodes for profit. It's just straight up professional infrastructure operators who really believe in the use case of NIM. And then we've got nodes for lulz, right? People who just want to kind of like try things out and see how far they can push things. And lately we've got what are called NIM squads. So what's starting to happen now is that the community all over the world are setting up their own kind of like decentralized hubs that not just run nodes, but they'll also develop small apps or get involved in NIM in a kind of much deeper level. So we have people who've been trying out kind of integrating NIM with the Brave browser. Or setting up kind of like integrating NIM into kind of like hardware routers, this sort of thing. So some really nice projects that are starting to develop in the community. So to wrap up this section, what we're really looking for here is definitely people who are interested in running NIM nodes. That QR code at the top there will take you straight to the operator guide where you'll find out more about the NIM token economics. You can get the binaries, guides, and so on. And then the one at the bottom, QR code at the bottom will take you to the NIM Exit Node Legal Forum. Now this is something that we set up recently because we're doing a project called Project Smoosh, which essentially means that we're going to smoosh the mixed nodes with the gateways, meaning all NIM nodes will actually be running either or by default. This is a little bit of an open question right now, so we're working very closely with our community to see how they feel about that. Because of course there is a certain nervousness around running exit nodes. So that's definitely something that we would like to have some open and honest discussions with everybody about tomorrow at the workshop. And in particular also talk about the Tor null policy, which is part of Project Smoosh. So at the moment, what we're running in terms of exit nodes is we're running a system where only certain kind of domains are allowed, and we're going to flip that over where it'll be a deny list instead based on the Tor null policy. So we are very open to hearing feedback for anyone who has comments on that. Moving on to the first application that we're building on top of the MixNet. Of course, the community has already been building applications. Why are we building a VPN? Now, a MixNet is an incredibly difficult thing for most of the world to understand or make use of. And we do have a little bit of a philosophy that, privacy should not feel like you need to learn how to, defeat the NSA all on your own or with a couple of buddies. Ideally, privacy should feel something that is easy, pleasurable, natural, in fact, something that you don't even need to think about. And so this is why we're building the NIM VPN. And what we want to achieve with the VPN primarily is to exactly get the best of both worlds. Now, of course, when you're using a 5-hop VPN, it's going to add latency. Like, there's no way around that. We're looking at various ways that we can optimize latency, but it just is a kind of trade-off. So what we're doing with the VPN is we're creating a kind of like two modes in one app, let's say, where for particular use cases like messaging or crypto transactions or things like that, where latency doesn't hugely matter, but where you have very vulnerable kind of communications going across, you can switch on your 5-hop MixNet. And then if you want to stream or do whatever else, you can switch over to a 2-hop a VPN mode instead. So this is what we're trying at the moment is to present this app that kind of attempts to achieve the best of both worlds and optimize for both latency and anonymity depending on what your use case is. These are measurements that Serinko took this morning in terms of latency. And I think we can get into a short demo, no?
Hey everyone, I'm Seren from DevRel at NIM. Do I have the 2 mics?
Yes.
This is interesting.
For recording.
Nice. Okay. So we just don't show pictures. We were like, let's do a little live demo. I always say what can go wrong when we do that, and in a conference with a conference internet. Now this thing completely disappeared.
There you go.
All right. So I'm gonna pull here 2 things. One, meanwhile, if any of you is running the internet here in the event, you can see this returns you this very address. You can test it on yourself, so you see that we're starting kind of from same like everyone else. And then I'm gonna pull this guy here, which also disappears. Okay, it should be here. Nice. We're gonna do tomorrow the entire workshop, how to install that, how to prepare, how to run that together. Thanks to our devs, we have a special sandbox environment only for this event. So if you're gonna be testing with us or following some links which we will be sharing already today, if you come by the table, you don't have to wait for tomorrow. We can do it completely async. Don't be surprised if after this event a lot of that stuff is not gonna work, because the whole decentralized network we talk about, well, the sandbox for this event is run by us, and we don't want that to be the future way how the Mixnet works, right? So we're gonna take that environment down, and then again present the mainnet, which will be working fully for all users around the world. So whoever's gonna be testing with us, just heads up, this is not gonna work forever, the setup which we're gonna present. However, let's hope it's working now. I'll start with a full Mixnet. You got the little description that it's better for payments, messaging, email, stuff like that. But we can dare to see how if it's gonna work with a video or something like that. The lock in front of me is printing, so it should be working. So remember, this is, and again, you can check if you connect it to CDC 37C3 address. It should return you the same IP as it's here. If you refresh now, let's give it a shot. There we go. We are in Frankfurt over Main, because we have chosen Germany as an exit gateway to have a shortest possible route, but it goes the full 5 hops. With that, we can do some measurements, see if we're gonna arrive anywhere close to the numbers which we got this morning. And then if that works, we can dare to play a video, which, it's still in testing environment, might work, might not. So basically what's happening here on the 5 hops, it means that it goes the full pathway with the entry gateway being the first one, then the 3 layers of the mix nodes, and then the exit gateway, which has, in this case, already smooshed the network requester and the open exit policy implemented. We got pretty good ping on 834 milliseconds the whole path. That's better than what we measured this morning. Yeah, not a crazy download. Upload's gonna be also probably somewhere there. But let's be, I pull out a video. We run an academy for node operators, so I'm just gonna put it to random time, so I'm not cheating with the preloaded buffer here. And we might be lucky, we might be not. Let's see.
Otherwise, we have to try the 2-hop.
Yeah, otherwise we're gonna go to the 2-hop setup. But we are, in some poor quality, we are playing a video over 5 hops Mixnet right now. This is the first time we do this in the front of the world. Enjoy. Let's give it a blast. this might not be that friendly with us on HD, and therefore what we can do is, you disconnect from all the things you want to have fully behind a MixNet, and then you disconnect from the MixNet itself. So I'm gonna be back in, in the internet here. The only caveat with that is that you do have to reconnect your connection manually now in this alpha stage, because we pushed everything to be on this deadline here. So there are some little details which need to be tweaked. You see I reconnected back, and let's go again. Now I'll choose 2Hop, and here you can choose where it's gonna exit. You probably know it from different VPN providers. Well, this is running without that. Let's go to, say, Ireland, and connect and see if that's gonna work.
Make sure you're following the status here. That will tell.
We can jump somewhere else. Remember, we connected to Ireland. Sound off, we don't need sound. And yeah, we're in Dublin. You can run these measurements again. And we're running on 2Hop, which means entry gateway, exit gateway directly without the mix nodes on fully HD YouTube. There is a difference still between that and what you would know as VPN, because what is still happening is that you and your client are breaking the packets and sending them through that gateway. So there is still the the protection against the size, the correlation, the volume and the time correlation, which Jaya was talking about. But with that said, that's pretty much all. If you want to see more, and we're gonna do some CLI and different setups with WireGuard and stuff like that, just find me around. I'll be down at the table again at 3 p.m. today for the rest of the day, whole rest of tomorrow, and then officially the workshop starts tomorrow at noon. And that at 3, the node operator one. So you are very welcome. I will pause this. You are very welcome to come and join us there. I'll be looking forward. Thank you.